All right, now a little bit of architecture stuff. Go back here. I love how my face blinks in and out. It's all right. All right. So we'll draw our hierarchy back in. This is just this more or less the same as we were talking about here, where we had our 3 switches. Okay. Now the thing about a switch network is there is only one path between stations. Or wait, you know what we're going to do? I'm going to draw that, and then I'm going to say, let's take a break, because it's a good time for a break, I think. We've been in here for an hour and a half. Can you put my face up, and I'll send these guys off? We'll finish drawing this later. That looks really bad. Oh, there's my face. All right, we're going to take a break now. It's 2:30. We will take a break until 2:40. So I will see you all in 10 minutes. Look, I got myself again. All right. So we'll go back to our little overhead, and we're going to draw our switches again. We don't need that one. Oh, there we go. All right. So I don't know why I'm drawing these hairy switches. So out here's all our clients, and we're very happy to have them. We understand here is going to be where our server is, and then our internet connection, our connection to another WAN. Now, since there's a single path between stations, that also means we basically have a single point of failure. So for example, if I'm coming in here or going here, I don't know, let's go out to here. So I got a single path between stations. If we have a break in our network, normally it's going to be a physical failure. So if a link fails, that means this is off the network. All right? Now, in a happy world, we would have a redundant link here. All right? So I could plug in a cable that goes across this here. But notice that makes a loop, right? So if I did this, let's go back and sort of rewind and say that link hasn't failed. If I plug in this redundant link, this is going to create a loop. So let's just draw it down here. I'll draw it mini. So here's our switch, here's our other switch, here's our other switch. And if we plug in this other line across here, that needs to be deactivated. This is called, and if you're working in spanning tree protocol, so these are trees, right? I got like a trunk of a tree, and then the branch and branches. So this is a spanning of trees. That's why they call it spanning tree protocol. What spanning tree protocol does is it deactivates a redundant link. Okay? This can be automatic. Now, can you guys see how this would detect automatically that there was a link, a redundant link here? Let's look back here. So if we look back at this diagram, let's imagine now that there's a link across here. And what happens again when A1 sends that first thing and it gets broadcast, the first frame comes out that gets broadcast, it gets broadcast down this link, and now we've added in another link, and it's broadcast here. Y'all can see that, right? So when it gets over here, this switch is now going to have 2 entries for A1 because of this redundant link we've added, right? Because of the loop. Where was our MAC address? It's right here. So A1 is now going to be, I guess I plugged it into port 1. Where am I drawing all these colors? Port 1 is A1. And remember, the MAC address can only appear once in the table. And so the switch needs to deactivate one of the ports. Deactivated. So I need to deactivate one of these 2 ports. So this switch, it's sort of its job. Now, which one is it going to deactivate? This is the scary part. Let me just go back to here. Right? I wanted to deactivate this one. All right? We've already drawn our little thing. This is the core, right? And these are the work groups. So I want to deactivate the line between the work groups because I need to keep the core as being the core. But I want you to think about sort of the speed of light here. So I sent the green frame. Remember, this is the learning frame where we're learning where A1 is. The learning frame goes out these two links at the same time. Which frame gets to switch 3 the first? This one gets there first. Y'all see that? So if you were the switch, which link are you going to deactivate? The latecomer. Do you guys follow me? So if I learn this one first, I'll be like, this is the right one. This is the cool. These are where the cool kids come down. This is the fast way to get there. This one is the one I'll deactivate. That's no good though, right? But I don't want that to happen. So if you don't say, this is under spanning tree, if the administrator doesn't say the wrong link is probably going to be deactivated. We'll just put probably. All right, so what we're going to end up with, I'll just draw that again. What we're going to end up with is our network is going to look like this, and this link will be deactivated, and then I got problems, right? Because remember, this was our core, and this is our work group. And so now all this traffic is coming out of the work group and going into the other work group. This is not the high capacity, high quality switch here. This is my switch I want there in case this other one goes down. Okay? So you have to actually go in and code. You actually go into your switch itself and code each switch as being what level of the tree they are. Is basically how it works. And so a higher level switch will sort of have priority over lower ones. And at that point, we're no longer plug and play. And I'm not going to tell you how to do this and what to do this, but this is not plug and play. They call this manageable. So a certain kind of switch, you pop up from a level of just a cheap switch that'll do everything sort of okay, to a switch that a lot of the things can be managed or programmed by an administrator. And again, I just want you to be aware of these features, and you need to know that they exist. We are not learning how to do them. This is like, we're the Network Plus people, not the CCNAs yet. When you go to work and you're going to be the big kid or whatever, you'll pick this stuff up, all right? So that's spanning tree. Let me make sure I got that going here. Oh, so let's say we've set this up. If we set this up correctly and there does get to be a failed link, I guess we'll go back to here. So then we've created our redundant link and a link fails. This will be reactivated. So it's deactivated as long as this link is okay. If this link fails, this one is reactivated. This happens in a few seconds, which is a long time in networking, okay? A few seconds means it's long enough to interfere with someone's phone call, and it's long enough that someone's web browser is going to time out on a connection. But it's not going to kill anything, and it's not bad. If you're supporting a phone system, though, it's not good. There's a different protocol that has to be way more programmed that will reactivate really quickly, but it's way more programmed. Okay, so that's spanning tree protocol. Spanning tree protocol. So that's what we talked about on this one. Now you know we got to do more stuff. So let's just flip that baby over. Look how pretty those are. I can't decide if I like the lines sometimes. Sometimes I like them blank, especially when I'm drawing diagrams. All right.